This week on Waterways, Little Venice Marathon targeting a hotspot, and Seagrass Restoration, a class project. The Florida Keys are often depicted as a pristine tropical paradise. But in the early 1990s, government officials were finding otherwise. Proof of human waste leaking into nearshore waters and canals forced the closure of many local beaches. It was soon determined that sewage was leaking from old septic tanks and cesspits through the porous limestone substrate that makes up the Keys. A plan was developed called the Wastewater Master Plan. The Master Plan outlined a process in which to maintain the integrity and balance of the marine ecosystem. Part of the plan highlighted areas called hotspots that needed the most immediate attention. One such hotspot was a community in Marathon called Little Venice.
Little Venice has a large number of on-site systems, septic tanks, and cesspools, and it's an area where there is known poor water quality in the canals.
This area was chosen just because of the fact that we have a combination of cesspits and we have a lot of canals that you will see that are further down towards the Vacacut Bridge area. People would go from door to door and visit their neighbors and be able to go fishing and enjoy the area because there are numerous canals.
Resembling the European city of Venice with a maze of canals lined with homes, Little Venice had an antiquated system for dealing with sewage. Therefore, the septic tanks are now being replaced with a central collection facility, also known as an advanced wastewater treatment plant. The Florida Keys Aqueduct Authority was chosen to lead the project.
The aqueduct is the water utility for the Keys. Since we own that infrastructure and maintain that infrastructure, again, we were the logical choice to design, develop, and maintain and operate sewer systems at various points within the county.
The transition from septic tanks and cesspits to a central system for Little Venice residents cost money. Even with grants and help from county and state funds, the homeowners still had to pay for their share.
Well, in Little Venice, we have we have a bunch of different ways and walks of life here. I mean, we have all sorts of bunch of nationalities, as well as we have some young families that are here, and we have a lot of retirees that have been here for many, many years that have made Little Venice their home. It does mean an impact on their finances in reference to paying for the hookups and paying the fee for the Aqueduct Authority, which I believe is like $4,200 for the hookup, and that is prorated for those that cannot afford it right off the bat. It's over a 20-year period on their taxes that comes on their tax bill to help cover it.
For some, the burden is heavy. But for a healthy marine ecosystem, it is most definitely worth it. But what is the guarantee that the project will be successful? With so much time, energy, and money spent on the upgrades, where is the proof that it is worth it? To answer that question, the Florida DEP asked the experts.
Originally, we were approached by Florida DEP to start this study because we've had experience in water quality in the sanctuary in the past. In fact, we do the monitoring for the Florida Keys National Marine Sanctuary, so it seemed like an obvious choice for us to just set up another little program in an area that we're very familiar with.
Joe Boyer and his team at Florida International University have an extensive water quality laboratory. And with expertise in microbial biology, they have monitored much of the South Florida marine ecosystem.
Without data, there's no record for whether what you're doing is going to work or not. In the past, people have remediated systems, but not really known if they worked or not. So here we have a chance to get plenty of information prior to the changing of the system and information after. Before and after effects can be quantified statistically, so there's no debate over whether it has a benefit or not.
The canals and nearshore water of Little Venice are monitored once a week. Data on total nitrogen, phosphorus, fecal coliform, and salinity are recorded. Water samples are collected for bacteriological analysis. The researchers look for fecal coliform and enterococci, which is an indicator of sewage. The goal is to develop a database prior to the construction of the wastewater treatment plant and after the project is complete to determine if there is a difference in the water quality due to remediation.
If these canals were really swimming areas, many times you would not be able to, they would be closed by the county. We see big differences in areas within the canals and offshore. We sample in the head of the canal. These are blind canals, so they end up close to the road. And we sample at the mouth of the canal and we sample offshore. And we see a gradient of worse water quality at the head of the canal, impaired water quality at the mouth, and then offshore, usually it's pretty good. And by offshore, I'm talking about 50, 100 feet offshore.
While Boyer and his team have been diligently collecting water quality information, construction and plumbing crews have been inching towards their goal. However, a change in contractors and off-target estimations have caused delays.
The plan for monitoring Little Venice was initially 4 years. 2 years prior to the conversion, 2 years after. Construction delays have caused us, not us, but have caused our database to be more than 2 years prior to finishing the construction. So we may run into problems in getting funding to continue the study afterwards.
As a pilot project, the process has been marred with problems, but the eventual goal is in sight. Residents of Little Venice have not only set a standard of commitment, but also one of patience.
Well, definitely, the people who have gone through that, even though it's a painful process at first, will be satisfied to know that they will have better water quality in their canals after the projects are completed.
Well, I feel strongly that we're moving in the right direction. I live in the Little Venice sewer system area, project area, so I'll be hooking up as well, and I'm impacted in the same way that the other families in that area are impacted. I think it's the right thing to do. It's going to, we're hoping to see a vast improvement in the quality of nearshore waters. That's going to help everyone.
Many people will benefit from the efforts and sacrifices of those involved with the Little Venice upgrades. Lessons are often learned from those who are first, and Little Venice is no exception.
Little Venice is the first central wastewater treatment upgrade in the Middle Keys, and it serves as a pilot project for future projects. The success of this project, will be used, if you would, as an example, for other projects that follow in the wastewater master plan.
The Little Venice project is important in a larger scale because although it's a localized system that we're studying, the results from this can be generalized to broader case of the Florida Keys themselves. Most of the Florida Keys are not sewered, they're in septic systems. So if we can show that upgrading one area of concentrated development in canals has an impact on the water quality in their shore, then I think we can use this as the basis for generating funds to upgrade other areas. And we may not have to redo this study again, because once we do it and show it, it will apply to all the other areas.
It is impressive and admirable that action has been taken in protecting our natural resources. The problem was identified, and now steps are being taken to fix that problem. Although scientists and researchers are confident that the water quality in Little Venice canals and near shore is sure to improve, they hope the proof will soon be in hand. Growing up in the Florida Keys is much like growing up anywhere. Except in the Keys, students are surrounded by some of the most biologically diverse ecosystems in North America. Conveying the significance of this and creating feelings of stewardship is the goal of many classrooms. Furthermore, students in the Florida Keys have unparalleled opportunities to learn in the greatest classroom of all, the outdoors. These are some of the reasons that these marine biology students from Coral Shores High School are out here. This time, they are working at restoring seagrass beds that have been damaged by boat propellers.
The Seagrass Restoration Project that we're doing is only part of what our marine studies students do. This is a field-based and project-based program or service learning program. The students take no tests. Their work is assessed by portfolio, which are web-based. Some of the other projects they do include reef assessment, artificial reef monitoring. They actually produced artificial reefs before. They also do water quality testing for the village of Islamorada. They have a monofilament recycling program, and they have a partnership with Island Dolphin Care.
In the classroom and from textbooks, these eager students were learning that seagrass beds are the so-called engine that runs the Keys ecosystem. Seagrass beds serve as nursery areas, hiding places, and feeding grounds for many different types of marine life. When seagrass beds are damaged, the health of the entire coral reef ecosystem is threatened.
I was fortunate enough to be invited to the classroom. Started out with just simple lectures talking about seagrass ecology, talking about prop scars and damage to seagrass that we have here in the Florida Keys. And the really neat thing is that the students really understood that, because in their activities of fishing or diving or what have you down here, they could see the prop scars that are very evident on almost every flat here in the Keys. So I think a lot of them kind of tuned in and said, hey, this will be cool that we can make a difference, or at least do something to help out the seagrass.
Inspired by the visit and discussion from Sean Meehan, the class enthusiastically sought to restore and protect damaged seagrass. With the intense boat traffic just offshore of Islamorada, the class from Coral Shores did not have to look far to find their project. However, restoration projects need funding, and so David Makepeace looked to Leslie Craig with the NOAA Restoration Center.
Our goals are kind of equal parts fisheries habitat restoration, and also getting the community involved. And as you'll be able to see here, there's lots of students involved in this project, so the education component is also really strong. And the site they've chosen, I'm really happy to see, is also one that should have a lot of people looking at it. There's a marina nearby. There's already a lot of boats going by this morning, and those are the main goals of the program.
Through a partnership between the NOAA Restoration Center, the EPA, and the National Fish and Wildlife Foundation, the project was part of the 5-Star program, which requires that proposals involve 5 partners. Most of the Keys seagrass beds are comprised of turtle grass. However, turtle grass is not very good at colonizing disturbed areas. When a seagrass bed is scarred by a boat propeller, it often destroys the substrate. Therefore, these students use a species called shoalgrass to stabilize the seafloor.
Now that's the ecological role, actually, of shoalgrass throughout the environment, is to sort of be what holds things together when conditions get bad. Just because shoalgrass has a much higher tolerance for varying environmental conditions, and it grows a lot faster.
What I have here is a bundle that was already made. What we have is we have basically 3 strands of grass in here, and we like to have at least 2 what are called apical meristems. An apical meristem looks like this. It's the part of the rhizome that's actually growing out. As this end just grows and stops, this just grows, makes a shoot, then grows a little bit more, makes another shoot. In our bundles here, we wrap them up with this little wire, and we have these, we bend the wire down and make these 2 little staples. What that does is when we drag out some dirt, we set this down in there, and they just help it stick a little better and hold the sediment together.
To speed up the growth of the newly planted seagrass in the damaged areas, the students use a tried and true growth accelerant, fertilizer. Installing a series of bird stakes, vertical PVC pipes topped with wooden blocks, and placing the stakes along a prop scar significantly reduces the time needed for a complete recovery.
The methods are quite simple. We identify a spot that has been destroyed by a propeller or vessel grounding. We measure that, we get a surface area, and then we put in bird stakes or roosting perches. We found out through research that bird defecation is really a great fertilizer for enhancing the growth of seagrass back into areas that have been destroyed and seagrass has been removed.
The students were quick to realize the obstacles in seagrass restoration. While their efforts were producing immediate effects, they realized that their site represented a fraction of the number of damaged sites throughout South Florida.
The Florida Keys National Marine Sanctuary has approximately, or a minimum of 600 groundings reported per year. That's just the reported ones. Of those, a majority are seagrass, approximately 80%.
Okay.
Most of those are small violations.
Right.
The officers write a ticket on scene like a traffic ticket.
On the reported 600 groundings, only about 80 require assessment and investigation for potential restoration. Ideally, funds to restore injured areas come from the boat owner or operator responsible. The Coral Shore students are restoring an orphan site, the equivalent of a hit and run in an automobile, in which the perpetrator is unknown, leaving the sanctuary without funding for restoration.
Our requirement is that we do a minimum of 150 square meters of prop scar restoration during the course of the grant. The grant is for $15,000. We look forward to exceeding far beyond our requirement of 150 square meters. In fact, when asked earlier, I said that we were going to continue repairing prop scars till the money ran out.
At 316 meters, the scar that was chosen for these students just happened to be the longest single scar to be restored in the Keys to date. And while these kids were busy planting stakes and shoalgrass, they were also learning a bunch of other stuff.
This project represents an integration of a lot of other subject areas, because there's mathematics in calculating the area of the prop scar. There's mathematics in the estimates of coverage done by the quadrat benthic characterization activities that they've done. Social science, social studies in the political and socioeconomic aspects of the resource management. And then there's the development of stewardship. This represents a service learning project where the service that they're doing for the environment is integrated with the curriculum.
Out of the classroom, no tired old textbooks. And with more stimuli than playing video games, surfing the net, and watching TV combined, the hands-on experience that these kids were enjoying is an example of the possibilities in combining education with action. But don't tell these kids, they're having too much fun.
This represents an opportunity for me to make a difference where I live. The grass flats of Florida Bay and the nearshore waters of the Keys were the playground of my youth. I was born here. In fact, born not too far inshore from where we are right here. And to get an opportunity to, in conjunction with the efforts of my students, to actually make a difference in the environment, and by that to also communicate to others the importance of making a difference in the environment, the importance of the seagrass, because if somebody's going to go to the trouble of restoring it, it must be valuable.
On weekends, as these students go fishing with their families, they'll see their prop scar slowly disappear. And as the years roll on, it may prove difficult to find the old scar. The old wound will have faded, but as long as there are careless boaters cruising Keys waters, there will be prop scars to repair. We can only hope that the commitment to protecting the marine environment shown by these high school students signals better days ahead for the seagrass meadows of the Florida Keys.